Hi, Volker. Welcome back.
Hi, welcome back. Was great to meet you at Java One. Yeah.
Yeah, exactly. And how was it your first Java one? No,
No. I joined, I think my first Java One was like 20 years ago or so.
it was the you attended a Java one in the year 2000, something like this, 2099, 2001.
No, I think my first Java One was when I joined Sun Microsystems back in 2005 or so, I think.
Hmm. How big
Uh,
was it back then,
it
2005?
was great. It was really big. It was in Moscone Center, like Java
East,
One
West,
for
also
Moscone
both
Center.
Mosconis,
Both.
right?
Yeah, both
But
sides of
no hotels involved, just Mosconis.
Sorry?
There were no hotels involved, just Moscone
No,
Center.
just Moscone. Yeah, just
Okay,
Moscone.
because my first one was in 2000, and they were both Mosconis, and I think in the near there was Marriott and all the hotels in the near of Mosconis. So Mosconi was
Okay.
too small.
Yeah, there were special meetings in the hotels nearby. Yes,
Yeah,
I
but this was in the evening, and in my case it was
yeah.
regular sessions. So
Okay. Oh wow,
yeah, yeah,
that's impressive. Yes,
yeah. And how do you like this Java one?
I actually liked it, but it might be my personal opinion, but it was not too big.
Hmm.
It was very. I had the impression it was very familiar atmosphere.
Hmm.
Maybe I also liked it because I knew a lot of people, so
Hmm.
it feels like coming home. Like I probably knew half of the attendees. I think it was a good size to talk a lot with people.
Yeah.
Like three tracks was also okay. It was you would hear most of the stuff which was offered. The Actually I also liked the catering. So
Yeah.
it was not just sandwiches or so. So yeah, overall, my had a very positive
And the coffee
impression.
was also good, right?
I'm not a coffee drinker, but
Ah.
yeah, but they had fruits and snacks and all that. Yeah, it was a nice
And the
conference. I
snacks
hope
were
they keep
from
it.
local, no, they were local cookies. So they were
Yeah.
like not just snacks. They were actually great snacks. So
Yeah.
actually too good. So I tried to avoid the cookies because otherwise, I would just eat cookies the entire day. And they were like
Yeah.
just red, like from local city or regional cookies. So we are in the minority because I was told that or told I asked, and 2/3 of the attendees were new.
Oh, really?
Yeah, I
Okay.
asked in my talk, and I think someone asked during the keynote, and there were like consistent results, like 2/3 new attendees,
Okay.
which means I'm really curious what happens next year because I also ask, like my first question is, how do you like Java One? Because I thought that just I'm strange because I like it,
Hmm.
but uh, everyone likes that. So I never heard something negative about this Java one, which is remarkable because it actually never happened in the past. Even the big Java ones, everyone complained about the food, about whatever, about the size, or there was always complaints about the old, even at some time Java one.
Hmm.
I like them, but I always heard complaints. So at this time, no complaint. The only complaint I heard, which is true, if you upload your presentation, it had to be in PowerPoint format, and I don't have PowerPoint, so I cheated. But what I did, I just renamed PDF to PPT and uploaded the presentation, and hope no one catch me, right? So, but this was the only complaint that the onboarding with the content management system for the speakers was a bit confusing for me. But I mean, this is like nothing, right? I mean, this is like I can always complain about such things. And what I have to say, I attended, I think, all the sessions I could, except if I talk, of course, then I talk, but before and after. And because everything was in one building and there was 15 minutes break, I could actually move from room to room and still have chat with people, right? So this was actually the best experience. What I remember, Java One back then, there was not enough time, to go through from session to session because it was just too big. So and
Yeah.
you had to exactly know where it is located. And later, I don't know whether they moved from Moscone because Moscone was by Oracle Cloud World, I think, and we spent time in 4 hotels. And this was even worse. You had to almost run, to catch these sessions between the hotels. And then they improved that, because I also remember one hotel was about mobile, the other one about enterprise, so I could stay in one hotel. But I was strange because I was also interested in mobile, right? So I spent a little bit of time there, and then walked to the other half, and this was my experience. And I don't know whether they attended the, how to call it, parties or meetings afterwards.
Yeah.
And they were also great, right? Because the music was not too loud. If the null pointer is played, you can move out and you can still have a conversation, which was never true in the old Java 1. So I remember there were parties which was so loud that I couldn't. I couldn't hear the. It was just. It was not right for a developer conference, I would say.
Yeah, I remember those days. Yes, in the hotels, I could never find my way around. I never knew in which one I was. There was these 4 hotels.
Yeah,
on the crossing, and you never knew where you were and which direction to go. I always had to go to the street to orient myself. Yeah.
So what I have to say, it is. So what next year can happen is then, if the old timers will reattend again. There are lots like Johann Voss and all the others, which usually always attended Java 1. I think we can easily double the amount of attendees, and then the challenge would be, to remain as it is, the same experience, because then you need a larger building, and should still work like this. But I will try to attend next year as well, because it was really good.
Yeah, let's see how they solve it. I'm interested. Yes.
Yeah,
but
let's see. Not that the next reinvent happens, right? So then we need a helicopter to move between the sessions. So in reinvent, there was another hotel, and I wanted just opened Google Maps, and there's like 40 minutes walk, and I said, okay, no way. Mission impossible. Okay. You are working now for AWS, right?
Yes, exactly.
How long? For how long? You know it?
Well, more than 5 years already. So
Okay.
5.5 years. Yes, quite some time. Yes.
And you are the Corretto.
Yeah, I'm working in the Amazon Corretto team. So we basically do 2 things. We create the public, free to use, open for everybody release of Corretto, and Corretto is basically OpenJDK downstream distribution, which we build, maintain, support, certify. We support the major platforms like Linux, Windows, Mac, x86, and ARM64. We support from Java 8, all the LTS versions, 8, 11, 17, 21, and soon 25, and always the latest non-LTS version for 6 months. I think we meanwhile have more than 500 artifacts. So it's quite excessive what we build, because it's not only these 5 versions which we have distributed on the 4 platforms or 6. It's also like we have tar.gc files, we have RPMs, we have Debian packages, then we have Windows installers, we have Docker containers, and this all adds up. So it's really quite a challenge to build all this. We certify every update release. We are members in the vulnerability group. We are very serious about security. Usually we manage to release our update releases the same day when Oracle lifts the embargo, usually a few hours after.
There's an embargo?
Yeah, I mean, if you're a member of the vulnerability group, Oracle shares the vulnerabilities, and then we agree which one will be fixed in the next quarterly security update release. But obviously, you cannot talk about this beforehand. So the release days are fixed in advance, and then, like on these days, everybody waits for Oracle to release. And when Oracle releases their JDK versions, they basically publish which CVEs have been fixed in the update releases, and then everybody else is free to do basically the same, to release its versions. And that's why I say we usually do this like a few hours after Microsoft. So, but the week before, such update releases are usually quite busy, because, as I said, we have to build and test and certify all this around 500 artifacts, because when we release all of them at once. So our customers can update and
how long this build runs with the 500 artifacts?
It runs for weeks, or at least a week, because like it's not a build, but we obviously run a lot of tests on these builds. Then we run the TCK certification, which is also quite long process, because it's like 100,000 of tests which you have to pass in order to claim SE compatibility. And this TCK testing actually also involves some part of manual testing for example, for printing or for sound, or mostly for the GUI, like AWT swing test and so on.
And okay, then how long just the build runs for Java 24 roughly?
The build itself is that's quite fast on a decent machine. That's just a few minutes. So the build is not the problem anymore. The build issues were fixed, like I would say that was around Java 8, 9. I don't even remember exactly when the whole build system was reworked. That was a huge effort. Before that, the build took really an hour or so. I remember that, but with the new build system.
Why is this faster now? Is this parallel or what?
Yeah, it was parallelized, and that's the main reason. Then things were implemented like the Java C server, which basically runs, and like you keep a process running, a Java C process running, and send him the files to compile.
Java C as a service.
Yeah, Java C as a service. I think this Java C server mode is only used for building the OpenJDK. I don't think that's like an official feature of Java C. But yeah.
And what is a part of OpenJDK, not the Corretto part, right? The Java C server?
No, this is all up. Yeah, so Corretto is a non-differentiating downstream distribution. We continuously have this discussion because some of our customers they ask us to add special features to Corretto, but another part of the customers, they insist that we stay on par with OpenJDK, because they might be afraid to get into vendor login with Amazon. So yeah, so we, like as I said, our team is basically vending two versions of JDK. The one is Corretto, and we also have our internal version, who is in Amazon, which is used by internal Amazon services. And we are much more liberal with our internal version. It's mostly downports. We do more aggressively internally, because, I mean, all the features we develop internally, and we contribute them all to upstream. So our goal is not to create a fork of OpenJDK in any way. We want to work for the benefit of everybody, and we are not interested in maintaining a fork. We want to get everything upstream, but as you might know, it's sometimes quite challenging to get bigger changes upstream, because you have to align with the community, with Oracle.
Yeah,
there are just constraints sometimes in the review, amount of reviewers that are available, in the amount of testing capabilities on Oracle side. So it takes time, especially larger features like, for example, the compact object headers, which my colleague Roman Kenke has implemented, which landed in OpenJDK 24, or Generation Shenandoah, also done.
Was Roman at Java 1? Because I met some of your colleagues. I forgot their names.
Roman was not at Java 1 this year. I met him later in Seattle. He was in Seattle because we had our internal Amazon conference called DevCon 2 weeks after Java 1. But he was at the JVMLS last year.
And the internal name was all about Java at Amazon, right?
Well, as always, like a lot of AI, but
yeah.
But yeah, we had a lot of good discussions about Java as well. Yeah, but to come back,
What I
yes.
remember is
Yes.
I had a chat with, I don't know whom at Devox. This was 1.5 years ago, and there were the OpenJDK people at Devox. And what they told me, I asked about features, and one feature was interesting. It's like caching for Java-Lang system logger to improve performance, but it was contributed to upstream. But it was created by Corretto team, as I remember. And so seems like what happens is that Corretto implements interesting, useful features, but they are always contributed back, right, to the to
Yes,
upstream.
as I said, that's our policy. You probably mentioned about async logging. That
Exactly.
was a feature, yeah, we implemented a time ago, and this is a good example because the it's basically the logging of the internal JDK logging,
Exactly.
like you can enable with xlog, or the log that is done by many of the XX trace or print options,
Mm-hmm.
and that works pretty well. But at our scale, we have services which are very latency sensitive, and because these logs eventually go to hard disk or to a socket, they can introduce some latencies, especially when some buffers overrun and you have to really persist it to disk. And this became really noticeable in some of our services. So we were very keen on fixing this. But this is a good example because this took a lot of iterations to finally land in the OpenJDK. So we first had an internal version of this because like we had the actual need to fix our services.
Mm-hmm.
So we did that, and then we tried to get it upstream. And after a few iterations, the implementation changed significantly. So we also used that new version internally to test it. And when we were really lucky with it, we tried again upstream, and then we finally got it in upstream. But in upstream, it is hard to downport such features to all the versions, which is understandable because a lot of people who are using older versions like 8 or 11 nowadays, they they are mostly interested in stability, right?
Mm-hmm.
I mean, there is always the people who don't want to update absolutely and want all the new features in in the older releases. But I think the vast majority of people is really interested in stability, and we understand that, and we are okay with this strategy to don't downport features, especially to older releases. So the older release gets, we only fix really serious
Mm-hmm.
bugs in upstream OpenJDK, which is fine. But then,
So I
as I
found the
said,
issue. It is the issue JDK 8229517, support for optional asynchronous buffered logging, and it was contributed by Amazon. And
Shin,
this
yes,
is hard to pronounce. I don't. Xin Liu,
Shin, yes, Shin
Shin,
Liu,
Shin
yeah,
Liu,
my
and
colleague, yeah,
Hohenze, Mr. Paul Hohenze.
yeah.
And this is interesting one, especially for me because I like to use the internal JDK logging on Lambda, for instance.
Mm-hmm.
Because what I do is Lambda is single threaded, and what I usually do, I try to avoid external frameworks, and I
Mm-hmm.
have an interface, a Java interface with method info and whatever, and inside the interface I use the Java-Lang system logger to log stuff, right?
Mm-hmm.
And it is redirected to CloudWatch anyway, so it is not like I don't have any specific requirements. And this issue is really, yeah, it is useful and interesting. And it was contributed upstream, which means it became, or it is available to everyone right now. So AWS, or Amazon contributed. Is it AWS or Amazon, or it doesn't matter? It's more AWS, right? Who contributes this
Yes,
actually?
I think we are part, like the Corretto team is part of AWS,
Okay.
but we obviously work for whole Amazon. So like a lot of the Amazon services which we support, which run on our JDKs, are part of Amazon.
Okay. This is an interesting topic because it means Corretto has clients at Amazon, like the store and whatever, Amazon Prime, maybe even, and AWS, right? Lambda and so forth.
Sure. I
Yeah.
mean, AWS is mostly the IT part, which does the cloud business, but we obviously also support our internal customers, like all the other Amazon parts, as you say, like Amazon Prime or the retail side or everything else.
Yeah, and interesting part is back then I used the Oracle JDK always because I thought, not I thought, it was, the heritage of Sun. And I said, okay, this is the thing. But people try to ask, no, why are you using this way, not picking OpenJDK? And I say, wait, because Oracle was good enough, and it didn't matter because what I usually did, I created Docker containers, and then I could use whatever I liked. And because I could use, I thought, okay, the canonical JDK is Oracle one. And then Corona happened and whatever, and I spent for years now time in serverless environment on Lambda. And how on Lambda works, what I like is I don't have to ship the JDK. I just say I would like to have the Java 21, and it just happens. And because Lambda uses Corretto, I said maybe it is wise to switch to Corretto. And at the beginning, I just used Corretto for Lambda, and now use Corretto for everything. So it means right now on my machine, I have Corretto 24, just to use Java 24. And what was stunned, as you remember, at Java 1, Corretto was announced. And I think in the airplane, I installed Java 24 Corretto. It was short after the announcement of Java 24, I was able to use the Corretto. Maybe one day later, I don't know. When you release that?
As I say, I think that happens within hours after Oracle releases. So we are.
Yeah, exactly. Because I remember in the airplane there was bad connection, but the first time I had I had the bandwidth, I downloaded the from Corretto Java 24, installed, and I'm just using that. And funny stuff, people suspected me to be like Oracle fanboy back then, and now I guess Corretto fanboy because I always use the Corretto one. But this is the reason most of my projects are serverless Lambda, so this is why I'm using this, and it works, and it is it is very easy to install. You don't have to register, go to Corretto, and you just download it, and it is working, right? So. Mm-hmm.
Yeah, I'm happy you like it. Yes, so that's our intention, to make it easy consumable, and that's what I mentioned before. That's why we have so many different distributions to basically make it simple for everybody to install it in the way they like. Actually, Corretto is also the default JDK in Amazon Linux. So if anybody is using Amazon Linux, the default Java which comes with Amazon Linux is Corretto as well, although it's not named Corretto. I think the packages are just named OpenJDK or Java or whatsoever, but it's the same Corretto which you can download.
And even more importantly, in code build. So I use code build a lot, and code build has an internal image. So I can say, I think Amazon Linux 7 now, and indirectly uses Corretto. And I opened quite a few issues because it took a long time until Java 21 became available in code build. And so you had to install it by yourself. It is just one liner, but it took like 10 seconds on every build, which I really complained, and I opened some issues. So the one criticism from me is to push Corretto even more internally, because I would expect Java 24 is available 1 hour after Oracle, and 1 hour later it is available in code builds, right? This would be perfect situation. But yeah, and in code build is important because you have Maven, yeah, right? So if we run Maven builds, it runs in code build, which is part of the code pipeline.
Okay. Yeah, I'm not aware. I don't know how the code build handles updates. I can try to check. Like I know that Lambda, for example, is only supporting LTS versions.
Yeah, exactly.
So,
but the code build was even worse. It was LTS was not supported by code build, so it was even slower. But no problem, because what you could do is you can just install with I forgot the command, with one liner. You had it, but it was for me waste of resources. Why I have to install over and over again? The Java 21 if it is available. Yeah. Okay, so what you mentioned something interesting. You said there's embargo regarding security issues. So it sounds to me like Amazon or AWS. Technically, Corretto is what? Amazon or AWS? You are AWS, right? Or you are Amazon?
Well, I'm part of the AWS organization, but that's
yeah, I know. So let's say then AWS, Microsoft, the same story, I guess. Azure people, not Microsoft, rather than Azure, and then SAP and all the others. So it sounds to me like everyone picks some security issues, solve them, and pushes back to upstream, and then everything is secure, right? So you need some like issue distribution system, not that one issue is solved twice by different providers, right?
Yeah, that's basically how it works. The infrastructure is quite quite limited. Like all the members of the vulnerability group, and that's true. That's the people you mentioned, like SAP, Azure, Microsoft, Red Hat, IBM. We all get the same information from Oracle. Oracle only fixes vulnerabilities in the latest release, like 24 currently for 2 update releases, and then all the update projects are run by the OpenJDK community, and we do downport the security issues. We decide the fixes. We decide if they are relevant for all the releases. Sometimes there are only issues in all the releases. Then we do the fixes ourselves. And the communication happens over an encrypted mailing list. So there is a vulndev mailing list. You have to sign become a member of the vulnerability group to get onto this mailing list, and all the communication is encrypted with PGP. And it's sometimes quite hard because all the communication, the patches, and so on, that only goes through this mailing list. So.
Okay, so
that's how the synchronization happens. Yes.
So what means is the Oracle fixes all the security issues in the recent one, but doesn't backport the issues to the older. And the job of the providers, if they like, is to backporting the security issues to older versions, right?
Yes, exactly. We have to make sure that all the older versions stay
okay.
secure. Yes.
And what I thought is that you share all the vulnerability issues to all distributions, and they are contributed back. But it seems like Oracle solves everything, and then or how does it work? So there's, let's say I will report security issue. It could be also solved by Corretto team, or it's always solved by Oracle first.
No, like there is basically 2 ways to report a security issue. You could either report it to Oracle directly or to the OpenJDK project.
OpenJDK. Let's say I do OpenJDK.
Yeah, this will also be handled like Oracle does the initial triage, and they ultimately decide which fixes they will put into the next update release in the next quarter, and then everybody is free to work on fixes. Especially because the members of the vulnerability group, sometimes they detect vulnerabilities themselves, and
exactly.
Then obviously they also usually they fix them, so they report them with a fix already.
Yeah, exactly. So what means is let's say you will fix the issue I found, will contribute back. Oracle will immediately apply to the latest release, and you will backport this issue or this fix to the older releases, right?
Yes.
Okay. Now
but the as I said, in order to become a member of the vulnerability group, you have to sign the OpenJDK vulnerability group document, and that's a quite big contract, and this basically makes sure that we always align, so nobody can fix a security issue. No single vendor can fix a security issue without the agreement of the group. So we have to agree in the group that either everybody fixes it or we postpone the fix to the next update release. So these discussions happen in the group, but usually we get an agreement based on the severity of the issues, and so it's actually also possible to get out of line security fixes, but I don't remember this happened in the last time. Usually, it's 3 months cadence is fine. But
so the
every release has then. I mean, the good thing is that in the end, every release, every vendor has the same fixes the same issues. So all the Java versions should be safe always and should be on the same security level. I think that's the important thing which the vulnerability group makes sure that it happens. Sorry, I interrupted you.
No, I interrupt constantly. So how it should be in our podcast. But there is one async logging feature. So we discussed that, which is already interesting.
Yeah.
And are there any other, interesting contributions from Corretto team which were used and are now available to everyone? And I'm interested, some features contributed by your team.
Yeah, I mean, as I mentioned before, like the project Lilliput, the compact object headers was done by Roman. That that was contributed by our team to upstream OpenJDK.
Yeah, explain what it is.
What it is. So in Java, each object has a header, which is traditionally was 16 bytes. This header is used to hold a pointer to the class, actually the type information for each object. And extra 8 bytes were used for various stuff, for example, to hold the hash code. If you called hash code on an object, it was also used during GC, for example, to store forwarding pointers, for locking, for different things. And but this header is quite big. If you imagine you have an object which only has an infield, which is like 4 bytes, right? Your object still consumes 20 bytes in the heap, which is like 5 times more, right? So if you have a lot of small objects, the overhead of the object headers can be significant. So in usual workloads, it's about like 20-30%, or it can be as big as 20-30% of the heap, just the headers. So the idea was to make it smaller, and that's what Lilliput does. It basically compressed the bits which get used, which you need in the header, and made it just 8 bytes long. So for real world workloads, this gives you a heap improvement of about 10-50%, as we measured for our applications. As I said, it depends a little bit on your workload. If you only have like huge 1 megabyte arrays objects, then obviously the savings will be a lot smaller. But for real world workloads, it's like 10-50%, which is nice, I think. There is actually a nice tool called Java Object Layout, JOL, which is also implemented by Alexei Shipilyov. He's a member of our team as well. And I recommend everybody to use this tool because it shows you the internal layout of objects. So you can, for example, use Java Object Layout, give it a type like Java lang string, for example, and it will say you how much bits it uses for the header, how much the fields take up space. Like all the reference, for example, are on a 64-bit architecture are 8 bytes, but then of course if you run with compressed OOPS mode, then references will only be 4 bytes. And Java Object Layout gives you this nice overview, and it also tells you like with compact objects with compressed OOPS, the object will use so many bytes in the heap. Without it, you use that many. Then you have compact class headers, and now Lilliput. So it gives you this overview of all the modes and tells you how much memory an object takes. So that can be quite interesting.
I took a look, and the interesting part is this a tile of the OpenJDK project. So this is
it's
OpenJDK/Joel, and this is written in Java. Seems like
it is written in Java. It makes though use of the unsafe API and some internal APIs, but yeah, it's still written in Java. But I know Alexei has a hard time. The more unsafe and other parts of the JDK get closed, it gets harder and harder to access these internals. But until now it still works.
But I remember the Lilliput feature was announced in the earlier Java ones, so it is an older feature, right? When it was introduced, you remember this?
Like, I think the work on Lilliput already goes on for at least 2 or 3 years, I think.
Longer than that. It was a Java one, and I remember this Lilliput with the smaller, or was it reInvent maybe? Maybe there was a talk on reInvent. So, but I thought it's longer than 3 years.
It might be like this project. I mean, it doesn't sound like rocket science, but in the end, it's really a lot of fine-grained work which have to be done, because OpenJDK is old. It has a lot of modes. Like, for example, it impacts GC, the change of the object header. So you have to implement this for all the GCs which are available. You have to implement it for all the JIT compilers. As I mentioned before, it impacts locking. It impacts. It had implications with Project Loom, with the lightweight threads, because they also needed locking. It has impacts, for example, with future projects like Project Valhalla, because Project Valhalla, which implements value objects, they also will need some bits in the object header. So a lot of implications which have to be solved and have to be thought about. For example, Roman has already the next version, Lilliput 2, available, which compresses the header from 8 bytes to 4 bytes. He has a working version, and we are testing this already internally, but it will definitely take probably at least 1 more year until this can be submitted or integrated upstream. Because
how much savings you are measuring right now, roughly?
Like from 8 to 4, again, like 5 to 10%. Like, obviously, the first savings from 16 to 8 were bigger, but it's still worth it, I think.
Okay, we had the async logging, then Lilliput, and it started in 2021. So I think it was reInvent talk, because
might be, yes.
And and confused with Java 1. And okay, and then what else? Any other interesting features? Which
I think the other big feature, incidentally, like Lilliput and Generation Shenandoah, they both went into 24. So Generation Shenandoah is the generational version of the Shenandoah garbage collector. So Shenandoah was initially developed by Red Hat, so the credits go to Red Hat. But meanwhile, it is supported by Amazon, because Roman and Alexei, they both work for the Corretto team now. But the generational version of Shenandoah was completely developed by Amazon. Again,
why you need it, or what does it? Which problem does it help?
So Shenandoah, like ZGC, is ultra low pause concurrent garbage collector, and the problem with concurrent garbage collectors is, especially if they try to be low latency, is that they try to do as few work as possible at the save point and do as much as possible concurrently. So they basically concurrently mark and scan the heap and compact, remove compact objects, and all this is done concurrently. But this also means that you need a good enough runway to do your work, because if you think about it, how this works, like a stop the world collector, like serial or parallel, they work at a save point. So they stop all the threads, they do all their work, and then application threads continue. Whereas with a concurrent garbage collector, your workload, your application sets are running full steam. So this means when a concurrent phase starts, it takes a snapshot at the beginning, how we call it. So that's it. It basically it does a save point, but at this save point, it basically only captures the valid routes. So it scans the stacks, the objects in JNI handles and so on. Basically, the root objects from which it creates a live analysis of all the live objects, right? But this is done at the beginning, and then the next phases, they are all concurrent. But in these concurrent phases, your application threads are running and allocating new objects, and these new objects are are not won't be collected until the next GC phase starts, the next GC round starts. So this means if you have a very high allocation rate, let's say your concurrent phase takes 1 second, but if in this second you allocate 1 gigabyte of heap, you basically need one gigabyte free space until the GC finishes and releases garbage before the next phase can start to collect the 1 gigabyte memory which you allocated in the 1 second in which the GC ran. So this was the problem of Shenandoah and also ZGC, that it basically needed almost like double the heap than G1GC. So if your application ran fine with G1GC and let's say with 4 gigabytes, you could get much lower GC latency with Shenandoah, but most of the time you needed, or you could need up to 8 gigabyte for it to run smoothly, especially if you had very high allocation rates. So the generational version of Shenandoah, and basically the same for applies to ZGC. That's why ZGC also implemented generational version, is that you basically the generational approach is to say that most objects in Java are young, right? So the GC starts, or the GC first only collects the young part. So both Shenandoah and ZGC, they are regional garbage correction. So you don't have a young generation and an old generation. You have regions, like thousands of regions. The region is usually 2 megabytes. But there are regions which are considered to belong to a young generation and other regions which are then old. So the GC only works on the young generation, on the young regions. And because there are fewer young regions, it works faster. So it can collect the young regions faster, and it can free memory much faster than when scanning the whole heap. And this is why now you don't need so much runway anymore. So we observed in our internal testing that we basically can run now with the same heap size as G1GC and still achieve much lower pause times. So
which is huge for multi-threaded workloads, right?
Yeah, it is huge if you have latency sensitive services, because now like we aim for sub-millisecond pause times by GC, and this means that GC actually won't contribute to your latencies. It's really other issues now. It's the operating system, it's I/O, it's kernel. Sometimes even kernel pauses are usually now become the bigger issue compared to GC. So GC isn't an issue anymore for latency sensitive services. Like I think 10 years or so ago, everybody said if you really need low latency, like sub-millisecond, you cannot implement a service in Java because it always has like at least 10 milliseconds or more pauses by GC. But I think with the new GCs, like generation Shenandoah, this isn't an issue anymore. So,
which is remarkable. It means Java is garbage collected, but there's no impact on latency.
Yeah, I think that's true, and that shows that Java technology can be used in a lot of areas where this was impossible years ago.
Could we say it is real time now?
Well, I wouldn't really call it real time, but it's...
Why not? I mean, if you say it is never longer than 1 millisecond, then it is real time, right? Because it's predictable. Or is it not, according to definition, is still not real time?
You cannot guarantee it. So, I mean, it is real time, probably for 99.99. I don't know how many nines of the time, but you cannot guarantee it or prove it.
But because I remember back then,
it's not real time, or how you can call it. I don't know.
Because back then, real time, there were real time JVMs, and how they worked is that in every, how to call it, clock cycle or whatever you call it in JVM, they collected the garbage. So there was never everything was slower but more predictable. So this is how.
Exactly.
Yeah.
So actually, one of the main authors of Generation Shenandoah is my colleague Kelvin Nielsen, and he actually worked on real-time JVM. He had his own company, and he was one of the authors of the JSR1 real-time Java, which was the first JSR written like 30 years ago or so. So yes, we have real-time competence in our team, and he works on Generation.
What was the name of his company?
I don't remember.
So in the year 2007, what I wrote a blog post on my blog with the title, "In 5 years, all application servers will be real-time capable." This was 2007, which I would say I was too optimistic because it would mean since 2012. But now we achieved that. It means they are, real-time capable. Not real-time, but if you would run Quarkus Micronode or Helidon on Corretto with or any OpenJDK with this feature, it should in most of the time they will never longer pause than 1 millisecond, right?
Yeah, definitely.
Another question is then the Shenandoah should be the default garbage collector. There is no reason to pick another one, right?
Yeah, there is a discussion going on. We had this discussion at after FOSDEM. We had the OpenJDK committers workshop, which we usually do after FOSDEM. There is usually one after the JVM Language Summit in summer in the US. And
how big is the workshop with the JDK committer workshop? So how many attendees do you have?
It's like, I would say, 30 people.
Wow.
30, 40 people. Yeah, it's decent. So we had this discussion, do we need so many garbage collectors anymore? And there is different ideas. Basically, remove parallel, for example, and because G1 can run, can be used as a replacement for parallel, or even serial, like you can configure Shenandoah or ZGC to behave as serial GC. There is as I said, there is a lot of overhead through this big number of GCs. Like we have serial parallel, G1, Shenandoah, and ZGC, 5 garbage collectors, and this has impact on a lot of things people usually don't realize. For example, the example I had before was Project Lilliput, the object headers, which need to be implemented for all these 5 garbage collectors. But also other things like JIT compilers, for example, they need so-called GC barriers for garbage collectors, and then again they are different for all the collectors. You have different GC barriers for the different GCs. So when you implement new JIT compiler features, you might run into this issue. Or when you port compiler to new architectures, you have to implement the barriers for all the GCs. For example, Roman is now working on adding Shenandoah support to the Graal JIT compiler. So the Graal compiler, which is part of the Graal project and used for ahead of time compiling to native image, that can also be used as a replacement for the CC2 JIT compiler in OpenJDK. And there is this ongoing project Galahad, which wants to reintroduce the Graal compiler as a JIT compiler into OpenJDK. It was part of OpenJDK, I think, between 9 and 15. Then it was removed again. So, for example, the Graal compiler
who removed that?
Oracle removed it
because they can just remove it in OpenJDK.
Yeah, I mean it's an implementation detail. This is not related to any standards.
Okay.
And actually, at that time, it was not so useful because the version that was in the OpenJDK at that time, as you might know, the Graal compiler is written in pure Java. So it involved a large overhead because the compiler basically spent the first seconds at startup to compile itself before it could even, or before it could at a decent performance compile your own Java methods. So this was a big startup delay, and the other issue with the Graal compiler was that it polluted your heap because it was written in Java. So all the native, all the data structures, the data it needed to compile a method were basically in your heap. So it could considerably increase the heap pressure on your application. So and at that time it was also not really faster than C2. So that's why it was then removed from OpenJDK. But meanwhile, there are technologies which help to solve this problem. So, for example, currently the Graal compiler itself can be compiled to a shared library with the Graal native image tool. So basically, this pre-compiles your Graal compiler, which is written in Java, into a native shared library, and then you load it. If you use the Graal compiler as a JIT, you just load this shared library through the JVM CI, the Java VM compiler interface, and then it doesn't has any impact on startup performance, but it also doesn't pollute your heap because.
So it means Oracle was not that evil. This was a good decision to remove it and now reintroduce it, right?
It was not because Oracle is evil. It was just it caused overhead in the project.
No. I just wanted to do it. It just was just fun. It was just technical reasons, to remove it now to reintroduce it. Exactly.
And there is a good reason, now to reintroduce it. So as I said, this project Galahad exists. Unfortunately, again, it takes a lot of time, but there is a lot of intricate technical issues which make it hard or which make it complicated to reintegrate it because the Graal project is a different project from the OpenJDK project, and the Graal project does several things. It's not only the Graal compiler, as I mentioned. They have the Graal native image tool, which is also based on the same compiler, and they have their polyglot truffle framework, which allows you to run other languages on top of the JVM. And one issue which accumulated over time is that these different parts of the Graal project, they have a lot of dependencies on each other. So, for example, the Graal compiler has or had a lot of dependencies and parts which were specific to truffle and native image baked into the Graal compiler. So what happened in the last 1 or 2 years is that the Graal team tries to detangle these parts again so that we can introduce a version of the Graal compiler back into the OpenJDK, which doesn't carry all these dependencies on truffle and native image, because we obviously don't want to have that in the OpenJDK. But on the other hand, we want to integrate it in such a way that the development of the compiler itself can be continued in OpenJDK, like as an upstream, right? So that we don't fork it and then get into the same situation we had before.
So Graal can become a part of Graal could become a part of OpenJDK, right? So this.
Yeah, I think that's the plan, but it just takes a lot of time because in the previous times when we had the Graal compiler in OpenJDK, it was basically a copy. It was always a copy of the Graal compiler from the Graal project, and the development happened in the Graal project. So from time to time, you just had to take basically a source drop from the Graal project and merge it into OpenJDK, and that is not satisfactory for OpenJDK because it's always a lot of work to have an external project which develops at its own speed and doesn't really take care of the developments in the OpenJDK. So that's the main reason for why Galahad takes so long, because we have to come to a version of Graal which can be developed in OpenJDK, but then still work with the Graal parts, with other Graal parts together.
So, but what we actually started discussion with is that the Shenandoah could, there's even a discussion whether it should be the default. I would say for most applications, it should be the default, unless you have very specific requirements, right?
Yeah, I think we plan to make it the default collector internally in Amazon, in our internal JDK build. But upstream, I don't know. I mean, this is also a political discussion because Oracle supports ZGC, So that's their collector.
But I mean, my project, which are unpolitical, are just technical. So no, if I'm outside, I could just pick Shenandoah.
You can always you can pick any GC, sure.
No, I know I can, but I mean, it is a good idea to do so, right?
Yeah.
And what's the difference between ZGC technical difference and the Shenandoah?
Oh, I'm not such a big GC expert.
Okay, but it should be similar features, right?
Yeah, it's similar features. Like ZGC uses a very special technique in that it maps the same physical memory at different virtual addresses. So this if you look with PS, for example, or PMAP at your Java process, which uses GCC, it will show you a very huge virtual address space. Sometimes, like if you have a heap of 32 gigabyte, the virtual address space might easily be like 300 gigabyte. This doesn't really mean that you use more physical memory. As I say, it uses the same amount of physical memory, but it maps it can map a physical page to several different virtual address spaces. That's why it looks so big. And then it uses a technique called colored pointers to basically decide if something has to be moved or has been marked or is in use. And in traditional garbage collectors, usually you use some bits in the marked word, for example, or in the reference to do this. So in ZGC, this is done with these colored pointers. On the other hand, ZGC cannot use, because of this, they cannot use compressed OOPs. So for heaps under 32 gigabyte, we think that Shenandoah is the better choice, because with compressed class pointers, again, you can save like 10 to 20% heap memory. But apart from them, I think the functionality is on par, and I think the fact that we have both of them helps overall, because they push each other.
Exactly. So I mean, this is very good, and you will have to perform, performance tests anyway. If you have a serious application, you have to test it, and then you can pick whatever works best for you. But my question was more about what could be the starting point, right? So ZGC or Shenandoah, and this is a good starting point, and then go ahead. Any other, interesting features? So you said pre-show we had a short discussion. You said maybe this is not that interesting topic, and now it gets more and more interesting, actually. So any other features which of Corretto which you remember, which are noteworthy? I guess this is thousands of commits, but maybe bigger something which is easy to
it's thousands of commits. Like we are actually the second, or after Oracle, the second biggest committer to the OpenJDK project.
So you overtook Red Hat?
Yeah, we overtook Red Hat. It's always like a fight between SAP, Red Hat, and Corretto. But
when you overtook, because I think in one point of time, so this is interesting, right? So okay, cool.
Yeah, I mean, I don't want to claim we are always the biggest. Like it varies for every release. So, for example, I think in the latest release, we had not that many commits, but we had the big ones like Lilliput or Shenandoah, which Generation Shenandoah, it was basically one commit in the end in OpenJDK upstream. Although, it was like thousands of internal commits before we pushed.
So the Red Hat is more, they have lots of commits and they are fixing Javadoc basically, right? And you have the big commit in the end. And no, I'm just kidding.
I think these are the SAP, Red Hat, and Amazon are the three big contributors, or the biggest ones.
But Microsoft as well, right? Microsoft we have to talk.
Yes,
about
there is this graph. This nice bar graph which is done by Sharat, I think, or Dalibor for every release. With this different colored bars depending on the number of commits.
Okay.
So you can look at it. But we are among the biggest in every release, yes. So yeah, it's like hundreds of commits. A bigger feature, like for example, we have for example the Amazon Corretto crypto provider, which is actually not part of OpenJDK, but it is a crypto provider which we use internally as the default crypto provider. Uh, and it's available for everybody for download. So you can just add it to your ClassPass or configure it in your security config file. It is based on initially it was based on OpenSSL's native libraries. So we mostly did this initially for performance reasons. So we saw significant improvements in encryption, decryption speed. Now it's based on AWS LC, which is a native crypto library supported and maintained by AWS. I think it's also it's still partially based on Boring SSL, which is self-derived from OpenSSL with improvements by Amazon. And so this is something we support as well. We just recently released a testing tool called Arctic. That can
but which features does it have? Just speed or additional crypto algorithm? You know that the crypto provider.
I think it's mostly speed. It supports the same set of algorithms as the default crypto provider in OpenJDK or Bouncy Castle. It has a FIPS mode as well, which is important for some people.
Very good.
Yeah. Maybe the last thing I want to mention is Arctic, which is actually a GUI testing tool. But we just released it like a few weeks ago. It's under the Corretto GitHub repository. This is probably not interesting for a lot of people, but for the few people who are interested in this might be really useful because it helps you to automate GUI testing. For example, JTREC, the JTREC tests have a lot of manual tests as well, especially for AWT. So this tool can help you to create a recording of your tests, and then you can automate the tests for updates and maintaining.
That is actually great. I actually surprised that Amazon or AWS does something like this, which would imply you have some Swing applications, right, to maintain.
No, it implies that we have to do the certification a lot of times, as I told you.
You're right. So you also have to test, the desktop stuff.
Yeah, exactly.
And this is what you use. Actually, great.
Yeah, so there's a pending blog post, which is still under internal review, which will get some more details. And we are also working on a wiki to get more documentation online. But it's good that we finally managed to open source it. And our colleagues from Adopt OpenJDK, for example, and from Red Hat and SAP, they are very keen on collaborating on this project. So we just today, when we finish our nice conversation, I will have lunch with my former SAP colleagues and the people from Adopt OpenJDK here in Waldorf, and we will talk about testing.
Then it was really a great conversation. So some insights how OpenJDK and Corretto is working internally. And thank you a lot. Where people can find you on the internet. And regarding Arctic, it is on the Corretto GitHub. So it's Corretto/Arctic with C. And this is, the GUI tool, open source tool by AWS Corretto team, which with some nice screenshots and even a video how to use that.
Yeah, so I just maybe as a closing note, I want to say that sometimes it might look from the outside as if there is a lot of competition in the Java ecosystem, and competition is always good, but I must say in general there is also a very big collaboration between all the different OpenJDK vendors, as I said before, like SAP, Red Hat, IBM, Adopt OpenJDK, Microsoft, Bellsoft, Azure, and Amazon. And I think all the people know each other very well, and we have a very good relation with each other. So there's a very good working environment.
And this is also my impression. And even the people from various teams worked once at Sun Microsoft, whatever. They know each other for a long time. So it is like, my impressions are a big community which works in different teams and they contribute to one project. So this is, and it was, I mentioned Evil Oracle, whatever, but this is just fun because this is what I hear a lot, from outside looks like, but if you attend the conferences, this is, I just noticed, the Microsoft people and the Oracle people, and we were all at Java 1 and everyone liked each other. There was lots of fun. So even informal conversation and, jokes or whatever. So I think it is a nice culture, I would say. What I observe from outside, I'm not a committer, but it's my impression, right?
Yeah, I agree. Totally agree.
Yeah. Where people can find you on the internet? You are still somewhere?
Yeah, like Googling my name will give you probably all the references. I'm on Twitter. Like
Volker Simonis, right?
Volker Simonis, yeah. Volker with V. German Volker, yeah.
Volker, yeah, exactly.
I think the name is quite unique. As far as I know, there is no other Volker Simonis on the internet. At least I haven't found another one. So
yeah, the singleton, the true singleton.
Exactly.
Okay. Thank you a lot. And maybe see you next time. Who knows, because
Yeah, it was fun. Thanks a lot for hosting me.
Bye.
Bye-bye.